Hello everyone, welcome to Marketing Research. This is a review for exam 4, a review for your fourth and last test. Okay, exam 4 will cover chapters 17 through 18 and chapter 4. Right, chapter 4 and 17 and 18, 3 chapters. Okay. All right, let's see what we have covered over the chapters. First, we talk about more further on the basics of basic data analysis. Okay? Basically, a more complex experimental design requires an alternative approach to the analysis presented earlier in the textbook. And this analysis still use the general linear model, GLM, that we have talked about. Okay, GLM. Okay, and then we talk about the F statistic in ANOVA. Sorry, excuse me. F is for one-way ANOVA. Okay. For ANOVA analysis variance, and for GLM, general linearized model, linear model, the basic statistic is the F statistic, an F curve. Okay. For F curve, just like in regression, involves the ratio of systematic variance over error variance. Okay. F statistic is a ratio between excuse me, systematic variance and error variance. Okay. To calculate F ratio, basically we partition the total variance into two parts. The one from within group variance, sum of square variance, and between groups and between group variance. So the total variance, or sum of square total equals sum of square error, some SSE, and sum square between, okay, between group variance, SSB. Okay. And I need you to look at this table here to see how SSB and SSC and SST is defined. Okay, in the sum square is defined within groups, and its associated degrees of freedom, and how the mean square is calculated. Mean square is calculated by dividing the sum of squares of each, like SSB, divided by its degrees of freedom, C minus 1. That's MSB, mean square between. Okay. Similarly, mean square error is the sum of square E within group error, within group the sum of square SSE divided by its degrees of freedom, Cn minus C. Okay. And then the ratio of these two, MSB and MSE, is our F statistic. So it's MSB over MSE. Okay. That's how we calculate that. That's normally the result from your Excel or other statistical software. Okay. And then talk about ANOVA. Using for complex experimental designs, randomized block designs, that allows you to control statistically for the impact of a nominal or ordinal control of blocking variables to do ANOVA. Okay, the linear model for randomized block design is this. It's simply the alpha is the J's treatment effort, beta is block effect. Alpha is the effect from the treatment, beta is the effect from the blocking variables and errors. Right? That's the ANOVA for complex experimental design, RBD, randomized block design. Okay. To conduct ANOVA to calculate the sum square total from treatment, blocks, and error. and then the total is defined using this equation here. Y double bar is the grand mean, okay, across all the treatments or all the blocks, rows and columns. Okay. That's total sum squared. And then here again, similarly, you need to understand this table that kind of like summarize all the calculations, equations for ANOVA, right? For randomized block design, right? You add the sum square for the blocks, is degree of freedom, divide that to get your mean square, and then you do that same thing for the treatment, between treatments, degrees of freedom, and then mean squares, okay? Do that for the errors, right? And then you have this, your sum square total, okay? And then you use the ratio of these two to get your F statistics. Also, we covered the factorial design. With the factorial design, it produces an experimental design fully implemented with two or more experimental variables. Observations are taken for every level of every experimental variable. Yeah. In factorial design, and one-way analysis variance and the multiple regression model share some things in common. Okay, the sum of the squares for each of the treatment vectors, rows or columns, is similar to the between group sum squares in the single factor ANOVA model. Okay, this is for factorial experiment. The Y is individual observation on the dependent variable, and then this mu is the grand mean, beta is the effect of factor B in the rows, alpha is the effect of factor A column treatment, and I is the interaction of alpha and beta, and then E is random error or residue. Okay. And of course, again, as I said, I'm not requiring to do anything like that for your group project. For the group project, I just need you to do some simple statistical analysis, and this is just for your knowledge and for your test. Okay. And then here is a summary table for the ANOVA for two-factor designs, factor A and B, treatment A and B, and the interaction of A and B. This is the sum of squares for treatment A and B, and the interaction and error and total. And then is their corresponding degrees of freedom and their mean squares, the sum square divided by its degrees of freedom. Okay. Then F ratio, you have 3, right? You have F ratio for treatment B, and F ratio for treatment A, and F ratio for error. Okay. Basically, when you interpret your results, you look at the F ratio for A and B and interaction. Okay. Then we talk about the for complex experimental design using within subject versus between subject, right? And there, make sure you know what that is. Within subject design, basically you have repeated measures because each treatment, with each treatment, the same subject is measured, the same person or same group of people, and put them under the same, under different experimental conditions. That's within subject, right? The same people, different test conditions. That's within, okay? And there is a demand effect. Make sure you understand that. That could be in your test. What is demand effect? A demand effect or a demand artifact results when the difference between treatment levels could be caused by awareness of the treatments rather than the genuine response to the treatments. Because the subject, the people, they're aware of the different treatments. Because you put people in, say, for example, different color of the room, they'll know, or they'll speculate. They may guess that, oh, you're testing for the difference between different colors of the room. So that's why, if you use a between subject design, put a group of people under only one condition, test condition, the result is more solid and more convincing. Okay. This chart shows very well the within and between subject design. Within, you have same person, under different conditions. Between, you have different people under different conditions. Okay? Then there's the issue of a balanced versus unbalanced designs, right? A balanced design is one which approximately equal number of subjects are exposed to each combination of treatment level. For different treatment levels, different groups, you have an equal number of people, okay? And then unbalanced, that's a balanced. And unbalanced, you have different number of people, okay? So plan comparison. You can do plan comparison. A plan comparison represents an alternative approach to examining specific differences between means and different effect combinations in ANOVA. Okay? The three key differences between planned, contrast, and the post hoc comparison. In planned, comparison is appropriate when the hypothesis exists ahead of time. Specifying the specific combination expected to yield a significant difference. Okay? And the analyst only tests the combination involved in the hypothesis. You only test that. Okay? A planned comparison contains more statistical power because you knew something in advance and planned that way. Okay? Versus post hoc examination. Data mining big data with this sequential chi-square test. When it comes to analyzing big data, marketing researchers work in very much of an exploratory mode. Okay? Data mining is much more about prediction than explanation, as I said. Right? They care only more about the explanation. Prediction. What might happen based on the trend, based on the past data. They don't care too much about why it happens. As long as they can predict sales, predict the future purchase, they're fine with that. Okay. They use automatic interaction detection, computers to search for variables within the data set that relate systematically to the dependent variables. Okay. And also, then we talk about the next following chapter. We talk about advanced topics in linear analytics in chapter 18. We talk about the covariance and correlation, and what the covariance is, and how it is defined and calculated, and what's correlation. Okay, covariance is absolute amount of association between two variables, determined by how a change in one variable corresponds systematically to a change in another. In other words, how the two vary together. That's what we call covariance, right? Covariance and covariance for x and y is calculated by that. Okay, this covariance, and that's for the top one is for sample covariance. The bottom one is for population covariance. Okay, it's straightforward. Then correlation. Correlation is a statistical measure of association between two variables expressed on a range of -1 to +1. Compared with the covariance, we tend to use correlation more. Which is more because it has this value between -1 and +1. We can easily see what kind of relationship is a positive or negative, or the magnitude of a correlation. It's a big correlation. Higher correlation was virtually no correlation. Closer to 1 or -1 is larger correlation. Close to 0, no correlation. So it's a standardized representation of covariance. Covariance standardized gives you the correlation coefficient. Okay, +1 positive perfect relationship, -1 perfect negative relationship, 0 no relationship. Okay, so it's very straightforward, very easy to see and evaluate, right? A correlation coefficient indicates both the magnitude and the direction. both the magnitude 0 to 1 or 0 to -1, yeah, the magnitude and direction, positive versus negative, right? Plus or minus. This is the equation for correlation coefficient. Remember, correlation coefficient of xy versus or yx, this are the same, okay, either way. Okay. So that's how you calculate. Very easy to see and use. Okay. In the test, I may give you a chart like this, showing you what kind of relationship is this. You can see this is a low positive, right? It's a positive, it's going this way, but it's not that high, right? It kind of scatters. Right? This is the high positive, right? And this is the perfect positive on straight line. Okay. This one, no correlation, right? Virtually no correlation. It's kind of scattered all over the place. This one seems to be a straight line here going this way. That's negative, but it's moderate, not too high, not too low. And this one, of course, is a perfect negative, okay? Perfect negative correlation. Then coefficient determination. Yeah, this one shows, it's called R squared, right? R squared is very important, very much used, right? If we want to know the proportional variance in y that overlaps x, then we can calculate coefficient determination, or R squared, right? It represents a measure of association between a dependent variable and the independent variable and employed to predict it. In other words, R squared normally is represented as a percentage or decimal point, right? But since it's squared, it's never going to be negative, right? It's always a positive number. It's always a number lower than 1. So it's between 0 and 1. The closer to 1, let's say it's 0.7, 0.8, or 70, 80%, it means that your model, your theory can explain like 70 or 80% of variance in y. Now that's pretty good, right? If you have a theory, you can use a few independent variables to predict the very dependent variables. You see your model can explain 70 to 80%. That's really good, right? On the other hand, if it's only R squared is only 0.2, 0.3, you can say, your theory is not that good. In actuality, in real world, if you can get the R squared 0.3, 0.4, you can celebrate. Okay, 0.3, 0.4, you can celebrate. Okay. Causality and explanation. To establish causality, you need three conditions. Okay. First one, temporal sequence. Cause first, then effect. Right. Concomitant variance. The two has to change together. Has to change, right? And then non-spurious association. I think I give you the example, in earlier lectures about the drowning and ice cream consumption during summer. Remember that, right? Ice cream consumption during that. That's a spurious association, right? Definitely, right? We can say eating ice cream get people drowned to death. That's not true, right? There's another reason for that. It's just summer because people are more likely to go out and swim, more likely to be drowned in water. Okay. In regression analysis, we provide evidence of concomitant variance in the form of a significant parameter coefficient. Right? The coefficient of the parameter, the slope, it gives you that evidence. Okay. And then residues. Residue means that the portion left over or unexplained after the predictor variables are included in model intended to provide y. Okay, you have y, the dependent variable. You have a bunch of x, that's predictor variables, and then you have the portion that's not explained, unexplained. That's your residue. Okay. And a major assumption of any generalized linear model, including linear regression, is that the residue terms are independent. We're assuming that. Okay? Most regression programs provide an easy mechanism to plot residues. You plot, you can see if it's there. When the plot reveal a random distribution of dots, then you can conclude that the error is white noise. Okay, white noise. But if not, pause here. Okay, so that's residue plot. The program, statistical programs will actually produce that one for you. You can look at to see if there is an issue here. Okay, if it's random distribution of dots, there's an error, it's just white noise, you're fine. Otherwise, you can say there is problem there. Okay. See, like this one on the left is good, it's okay. This on the right seems to be a problem. You see that there seems to be a line here, a trend here, a pattern here. Okay. And then we talk about the regression and regression to do some explanation, using the regression as a way to predict, right? You can select your dependent variable and independent variable based on your research questions. For your group project, remember, I'm going to ask you to have attitude type of questions, opinion attitude questions using Likert scale. You can use that as your dependent variables. And then you can choose some independent variables, such as demographics, age, gender, income, blah, 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 okay? And you can select any relevant control variables available in the data set and include as an additional independent variable, okay? You can perform multiple regression with appropriate software. For your class, actually you do a simple regression, or you can do multiple regression, a few very independent ones, okay? Then you interpret your F and R squared. Remember, F shows if the F ratio and then the p-value shows if it's significant, right? And then R squared shows you what the percentage of variance explained, okay? And also, let me see again, that skip that. Using regression for prediction. Not all regressions are intended to explain some dependent variables. At times, your concern is merely prediction. Remember, they just want to predict. You don't try to explain. Explain is harder, right? Explain is harder. Prediction is easier. You can use that for some practical purposes. Okay, that's regression and prediction. Okay, this one here show you the actual versus predicted. Okay, using this regression line. Okay, and then time series analysis, time series models place an emphasis on prediction over explanation. You can extrapolate, okay, to predict. The goal is to forecast some dependent variables for a future time period. You have the current period, past, then you extrapolate to forecast the future. Okay, there is an autocorrelation issue here, right? Autocorrelation that could be in your test refers to the fact that observations from different time periods are almost always correlated with each other. Yeah, that's autocorrelation. Okay, so the residues are likely to be independent of each other without corrective measures. Okay, and ordinary least square method. Okay, this is a straightforward mathematical technique that guarantees the resulting straight line will produce the least possible total error in using X predict Y. Basically, in ordinary least square, the distances from the dots to the line added together is minimum, is the least. That's why it's called ordinary least squares. Okay. Using square deviations, okay. Sum of square errors, SSE, is minimized. Okay, that's what this is about. Okay, this is regression equation and parameter estimate. This is your dependent variable, your intercept, slope, and independent variable and error term. This is how your slope B1 is calculated, how your B0 is calculated. Okay. You do Excel, use software is going to be calculated for you automatically, of course. Okay. And the statistical significance of your regression model is use F test, okay, just like ANOVA. Okay, this is your F statistics, and mass regression, mean square regression over mean square error. So calculate the F, and then we look at the p-value to see if it's significant. If p is closer to 0, it's significant. There's significant, right? If p is larger than like pretty big, over 0.05, then it's not. Then R squared, coefficient determination, right? Coefficient determination is the proportion of variance explained. How much of a variance can be explained by your model? That's your R squared. Okay? It's sum square regression divided by sum square total. Okay? It's always a positive number. Okay? And then in chapter 4, we talk about the human side of marketing research and some ethical issues. Like who should be the one to do the research? You can use outside agencies or in-house agencies. Outside versus inside. Okay, outside interest. There are pros and cons of each. Okay, do it yourself or let somebody else do it. Okay? When do we want to use outside agency? When you try to get a fresh perspective, objectivity, with some special expertise that is needed, you don't have. Okay? Or sometimes local expertise is needed. Okay? When do you use the in-house research? You want to do it quick, right? You want to you need a collaboration from employees and to save money. It's cheaper. Okay? That's and also secrecy concern. You don't want your trade secret to be known by your competitors or outside the world. Okay? Advantages of each. Okay, I'm sure you understand all this here. And then research suppliers and contractors. There are research suppliers, commercial ones, provide marketing research services for you. There are syndicated services. Okay, and there's standardized services providers. Okay. And then there's a limited service suppliers. It's only certain things. There's a full service suppliers and customer research just for you, specifically for one client. Okay. And then they talk about the size of company research firms. Small, less than 100, medium size, 100 to 500, larger, over 500 firm, or 500 employees. Sorry. And for mid-sized firms, typically the type of jobs, positions available: director of marketing research, research analyst, research associate, research assistant, and these are the ones that probably you're going to start out with if you join a marketing research agency. Okay? And the managers of decision support system, CRM system, forecast analyst, all possible one. Here is an example of a large market research company's organizational chart. Under the director of marketing research, you have those new product research director, customer satisfaction, strategic marketing, decision support, and electronic media, different kind of directors for different groups. And then there are the entry-level jobs, okay, detailed jobs. Okay. And there are conflicts. There may be conflict between marketing management and marketing research. The source of conflict could be from the criticisms, right? Being fighting for money, the time issues, okay? The source of errors when studies are rushed, right? Conducting study that is not needed, for example, wrong issues addressed, sampling difficulties, okay, all could lead to conflicts, inadequate data analysis, not done right, okay, and intuitive decision making. Managers sometimes resist marketing research because it's not against their intuitions. It's not against their intuitions. Intuition is not a replacement for informed market intelligence. Okay, you have to emphasize that, insist on that. Future decision based on past evidence can manage ways to predict future, but researchers measure only the current and past. Okay, really use the past to predict the future. Okay. There are ethical issues in marketing research. The ethical questions are philosophical ones, okay, and this something to do with the morals and behaviors. What is considered ethical versus unethical. Okay, there is the ethical dilemma. Okay, that's a situation when one chooses from alternative course of action, each with different ethical implications. Okay. There are philosophical approach. There is a relativism approach. Okay, it reflects the degree to which one rejects moral standards in favor of accountability of some action. Reject absolute principles in favor of situation-based evaluation. Then there's idealism, the degree which one bases one's morality on moral standards. Okay, remember the golden rule, right? What is golden rule? Okay, do unto others what you want others to do unto yourself. Basically, if you do not want others to do this on yourself, you do not want to do it on others. The golden rule. I can tell you, it's the same rule prevalent in East, West, all of the world, like entire humanity. Okay. Then we talk about the rights and obligation of marketing participants' rights to privacy, active research, okay, let's read that. Passive research, okay, with this obtrusive, non-obtrusive observations, implicit consent or the implicit consent, okay, and obligation to be truthful, okay, confidentiality issues, okay, deceptions in research, and the right to be informed experimental designs, placebo effect, right? Was a placebo, was a debriefing, briefing in the head of study, debriefing afterwards, okay, okay. Protecting from harm, question to ask to avoid harming a participant, okay. And an IRB stands for Institutional Review Board. Institutional Review Board, you have to get their approval when you use human subjects in your research. Okay. And then we talk about rights and obligations of a client sponsor, okay, sponsorship, and advocacy research, and rights and obligations of a researcher. Okay. There are professional organizations like American Marketing Association, AMA, etc., Marketing Research Society. Okay. And the research should not represent a sales pitch, right? It should provide name of anonymous respondents, provide the names of it should not provide names of anonymous, keep their anonymity, right? And it should not breach confidentiality of research with the client, okay? Should not, represent multiple firms competing in the same market. Should not disseminate false or misleading results. Okay? Be truthful. Okay? You should not plagiarize the work of other researchers. I'm sure you know that. Okay? Should not violate the integrity of data gathered. process. Okay. There are research that is not research, that's pseudo research. Pseudo research. There's a push-pull telemarketing, under the disguise of research, they're not research. There's service and monitoring, right? Monitoring, that's not research. Okay, that's not the setting. Okay, and then misrepresentation of research. Honesty in presenting results, honesty in reporting errors and limitations, and confidentiality. Okay. The role of society at large, right? Marketing research offers benefits for individual members and for society at large. The potential benefit of research should always outweigh the burden placed on members of society. And keep that in mind, okay? Being society, individuals all have ethical responsibilities. And marketing research value is diminished when any party breaches the responsibility. So I think that's all I have for this chapter, for these chapters, for this review. And you're going to have the test coming up. And good luck with your test. I'll see you and talk to you later. Thank you, guys. Goodbye.